So if you're making a calculation on the four-stroke piston engine brake horsepower, this could be across gasoline or diesel, stay tuned to this lecture. The first thing you'll need is the specification. So assume you're working with a V6 3.7 inch bore by 3.4 inch stroke V6 automobile gasoline powered four-stroke piston engine. You'll need the number of cylinders, the bore and stroke in inches, and the maximum torque value, in this case 272 foot-pounds at 3,400 RPM. So this is relevant to a 2011 Buick Enclave automobile. So the first thing we need to do is calculate the brake mean effective pressure in PSI. This is the ratio between the torque value in foot-pounds divided into the cubic inch displacement times 150.8. So first we'll just calculate the cubic inch displacement of this engine. So we have the bore as in the diameter of a circle divided by 2 for radius squared times pi, so we have cross-sectional area, then times the piston stroke per cylinder times 6 cylinders. So that's 219.34 cubic inches of displacement for the entire engine. So then we have this ratio here. So in a four-stroke piston engine, for example, gasoline or diesel, we have 4 piston strokes per 1 duty cycle. So air and fuel intake, compression, ignition, power, and then exhaust, and then restarts. So that is the descriptor of a 4-stroke duty cycle for a gas piston engine. In that case, if 1 foot-pound of torque is developed for every 1 cubic inch of displacement, then there is exactly 150.8 pounds per square inch of brake mean effective pressure in PSI, right? So we can make this ratio, and then we can calculate 187 pounds per square inch. So then we use this formula here, Planck over 33,000. So the P is the brake mean effective pressure in PSI. The L is the piston stroke in feet, so we have to divide this into 12 to get the piston stroke in feet. So 0.283 feet is the piston stroke. Then we have the piston area, so that is again the bore, the diameter of a circle, divided by 2 for radius squared times pi. So we have 10.75 square inches of piston area, excluding domed and dished piston metric. So that may or may not have to be added to the value. So next we have the number of power strokes per minute. And in a 4-stroke duty cycle piston engine, that value is exactly 1/2 the RPM. So in a 2-stroke piston engine like a chainsaw or a string trimmer 2-stroke piston engine, the number of power strokes is equal to the RPM. So in this case we divide the RPM into 2. For 1700 power strokes at 3,400 RPM. Then K is the number of cylinders, so 6 cylinders. So if we multiply Planck and then divide it into 33,000, we calculate 175.8 bhp brake horsepower at 3,400 RPM. Thank you for watching this lecture and have a great day.